student. Good afternoon. How are you all? So have you all taken lunch? Yes? No, okay, that's good. So today we are going to study the new chapter, and I will do one activity, or I will show you one activity. Just look this activity very nicely. Okay? Yes. See, this is she is the student, and how she cut so sharply. She has cut the knife, right? Cutted the wooden cardboard like this. See? Yes, it is divided into two parts. Yes. Now go. Thank you. Yes. See. Now you have seen that how the students have used the sharpened knife to cut the fruit. Yes, like this it has divided. Yes or no, student? Yes. So what will happen if the fruit is cut from the blunt side? Yes? Fruit will not be able to be cut. Yes. So we have to cut at sharpened point, not at blunt side. Right? Yes. Now students, suppose I am keeping my nail, okay, and suppose that it's a hammer. Hammer is there, and I fix the nail on a wall with the help of hammer. Okay, just suppose it. So what will happen? Yes student, suppose this is the hammer, and I have kept my nails here, pointed point. Then what will happen? Yes when I okay, yes Suman, that when I nail on the wall with the help of a hammer, I have kept the pointed end towards the wall first, right? At that time my nail was fixed, but when I tried doing this from the opposite direction, I wasn't able to, right? Yes Suman, very nice. Yes. Now, do you think, student, if some kind of force was being applied on the wall when I do this experiment, then do you think so that any kind of force are applying? Yes or no? Yes. Yeah. So if the force was being applied on a specific area only, student, or in any area part, or in only in a specific area? Yes. Okay. Yes. So today we are going to study about the topic as pressure. Okay. See, suppose, student, I need this bottle is there. Here's this bottle. I need more pressure to open this because it is not easily open, right? When I have applied more pressure, more force, then only the bottle the lid of the bottle has opened, right? Yes. So the force acting on a unit area of a surface is called pressure, and the formula of pressure is force per area on which it acts. Note it down, student, that the area is in the denominator in the above expression. So the smaller the area, larger the pressure on a surface of the same force, right? Pressure formula is force per area, right? So large force must be there and smaller area is required. Okay? So the area is in the denominator in the above expression. Pressure is equal to force per area. So the smaller the area, larger the pressure on the surface for the same force. The area of the pointed end of the nail is much smaller than that of its head. Alright? The same force therefore produces a pressure sufficient to push the pointed end of the nail into the wall. Okay? So therefore produces a pressure sufficient to push this pointed end of the nail into the wall. Okay? Understood, student? Yes. Now, Why do the potters place a round piece of cloth on their heads when they have to carry heavy loads? Yes. Why do the potters place a round piece of cloth on their heads when they have to carry heavy loads? What's the reason, student? Yes. Come on. Yes, because they will get then they will get more pressure, right? Yes, good. Now, pressure formula is P is equal to F by A, or force per area. Is it true or false? Yes, student. Yes, pressure formula is P is equal to force per area. Is it true or false? Sameer, Bittu, Dipali Puri, Sonam Bharti left. Yes, come on, quickly respond. It's true, right? Yes. And which ones should be bigger, larger, and which ones should be smaller, student? Force should be larger, okay, and area should be smaller, right? Yes, very nice. Now, student, have you ever played with water balloon like this in the occasion of the Holi? Have you ever played? Yes. Who are the student who has done naughty things with the balloon to the other student? Yes, raise their hand. I knew that Bittu and Suman definitely have done this activity. Yes. Other than that, okay, Swati also involved in this. Okay. So you do with your brother? Okay, fine. Yes. So what they did to in order to make a water balloon? Yes. If you have made this, then you know now that how it has made. So now, yes. Okay. Either with the help of the pichkari or with the tap. Okay. You place the balloon on the opening and then fill the balloon with the water, right? Yes. Okay. Okay, Suman. Fine. So, if the balloon is inflated, yes. Okay, yes. That's true. Now, watch one video. Yes. No, I'm sorry, no video this time. Yesterday. So, yes. So students, how liquids exert pressure? Do tell me that how liquids exert pressure. Where you are finding that liquids can exert pressure. When you throw this balloon with the pressure, then what is happening? Yes. Come on. Okay. Great. Yes. So student, liquids also exert pressure. The characteristics of liquid pressure are pressure exerted by water at the bottom of the container depends on the height of its column. Okay. Pressure exerted by water at the bottom of the container depends on the height of its column. Then second part is a liquid exerts pressure on the walls of the container and liquid exert equal pressure at the same depth. There are three important characteristics of liquid pressure are pressure exerted by water at the bottom of the container depends on the height of its column. A liquid exerts pressure on the walls of the container. Liquid exert equal pressure at the same depth. Alright? Yes? Any doubt, student? No? Okay. Now, I have seen fountains of water coming out of the leaking joints or holes in pipes of supplying water. Why is it so? I have seen fountains of water coming out of the leaking joints or holes in pipes of supplying water. Why is it so? Have you ever seen fountains of water? Yes. What's the reason that they are doing? They are putting some of the leaky joints or holes in that pipe or in fountains. Yes. So that more pressure is there. Okay. So that more water can come. All right. So that water goes to more distance. Yes. Have you seen the fountain? That fountain is here only, but how water flow this side, that side, this side, right? So this is the pressure. That is because of the pressure, student. All right. Yes. Now a container is filled with water as shown in the given figure, right? So which of the following statement is correct about pressure of water? A, B, C are there. Now pressure at A is greater than pressure at B is greater than pressure at C. Pressure at A is equal to pressure at B is equal to pressure at C. Then pressure at A is smaller than pressure at B, and pressure at B is greater than pressure at C. Then pressure at A is smaller than pressure at B, and pressure at B is smaller than pressure at C. Yes. What could be the answer, student? Yes, quickly respond. Yes, student. Come on. Yes, you are right. That pressure at C exerts more pressure, give more pressure than pressure at B, and then pressure at A, because the pressure are more in depth. Alright? Yes, very good. Now students, just like liquid exert pressure, do gases also exert pressure? What do you think? Just now we have seen that how liquid exert pressure. Yes, the same way how gases also exert pressure. Yes, do you think so? Okay. Bittu, Suman, Sneha said no. Okay. And rest are the students are saying yes. Okay. So let's check it out. Who are the students are correct? Okay. Please watch this video.
We have already learned liquids and solids exerts pressure. But what about gases? Gases also exerts pressure. Let's see how gases exerts pressure. You can see a inflated balloon in my hand. I had blown this. So the balloon is having excess of air inside it. The air inside the balloon is trying to escape it from it, which means air is applying a force on the surface of the balloon. So we can say that air is exerting a pressure on the surface of the balloon. So students, we have learned that gases also exerts pressure.
Yes, students. What you have learned, what you have observed in this video. Yes. Yes. That gases also exerts pressure. Alright. That how inflated air wants to get outside. Yes. Of the balloon. Yes. Right. So student, if we blow air in the balloon and yes, then when that man blow the air, then what you have observed it? Yes. That the balloon get inflated. Yes. And if you open the mouth of the balloon, then we to close in the mouth of the balloon, then what will happen? Then that balloon will get deflated, right? Yes. Now to make some holes in the balloon, okay, if we will now do one hole in the balloon and now try to blow air in the balloon, will it be happen, students? Sometimes now we will, when we buy balloon from the shop, then you must have observed this, right? Then we try to like this with the help of balloon, but we're not able to do, right? Why? Yes. will not be able to blow air in the balloon, right? Yes. So we are going to study about gases exerts pressure, right? Yes. So yes, gases also exert pressure on the walls of the container. You have seen this in video very well, right? Yes. Now student, what happens to the air in the bicycle tube when it has a puncture? Yes. What is happening to that air, to the air in the bicycle tube when it has a puncture? Yes. Then the tube get inflated, deflated, right? Yes. That is why it has happened. Yes. Now, fluids exert pressure on the walls of the container. It is true or false, student? Fluids exert pressure on the walls of the air container. It is true or false? Yes. Come on, give your answer quickly. Quickly respond, student. Bittu, Dipali Puri left. Yes. Yes, student. Okay, yes, true. So let's recapitulate our class today. We have learnt about pressure, how fluids exert pressure. We have defined pressure along with its formula. Formula is pressure is equal to force per area. Yes. Then we have demonstrated you the action of pressure exerted by liquids. Then pressure exerted by gases. Then different characteristic of liquid pressure with an appropriate example. And the significance of pressure in daily life, right? Yes. Now it's your homework. Two women are of the same height. One wears sandals with pointed heels while the other wears sandals with flat soles. Which one would feel more comfortable while walking on the sandy beach? Give reason. And it is difficult to cut cloth using pair of scissors with blunt blades. You have to explain it. Now, this is your activity. You have to take a tumbler and fill it with water. Cover the mouth of the tumbler with a thick card similar to that of the postcard. Hold the tumbler with one hand while keeping the card pressed to its mouth with your other hand. Turn the tumbler upside down while keeping the card pressed to its mouth. Make sure that the tumbler is held vertical. Gently remove the hand pressing the card. What do you observe? Does the card get detached, allowing the water to spill? With a little practice, you will find that the card continues to hold water in the tumbler even after it is not supported by your hand. Also try this activity by using a piece of cloth to hold the tumbler in an upside down position. Okay, so this is your activity, student. I will give you time to do this. Yes, till then, good day. We will meet in the next class. Have a very wonderful day, student. Bye bye. Take care.